Alright.
Alright, so we have the sun. I'm only going to keep a little bit of it in there. Totally out of scale. If this rust would be burning up. Alright, but this is the Earth. And right now I'm just going to leave the moon out of the equation. The pull of the sun to the Earth is tremendous. Even though it's 93 million miles away, the pull of the sun to the Earth is huge. So the pull of the sun to here is pretty much the same as the sun to here, which is pretty much the same as the sun to here. Subtle differences will lead to a little bit of what they call solar bulges, but overall, the sun is not a major factor with the tides. However, the moon is. So now let's put the moon right here. Now, even though the moon, its pull is far less on the Earth than the sun's is, the moon is a much bigger factor when it comes to tides because the moon is closer. Its pull isn't stronger, but now the pull makes a difference. And let me explain. Moon to, let's say, point A, pretty strong. Moon to point B, not as strong. Moon to point C, the weakest. So what happens is the moon pulls A more than it pulls B or C. Now the Earth pulls the moon, but the moon also pulls the Earth. So what we have here is we have the moon pulling A a little bit stronger, so that pulls the water. Now it's pulling B as well more than it's pulling C, so this allows the water that's at C not to get pulled as much, and it kind of builds up. So you have a lunar bulge, meaning a tide here and a tide here. Now, if the sun were a major factor when it comes to the tides, it would put high tide here and high tide here. But it's not a major factor. Do not confuse this with thinking that the sun does not have a huge pull to the Earth. It does have a huge pull to the Earth. But relatively speaking, the pull to the sun here, here, and here is pretty similar. So that explains why the moon is more of a factor when it comes to the tides. Now, what does this do? This puts high tide at here and here, at what we called before A and C. The sun would put tides, let's call this D and E, so that doesn't let the high tide at A and C get huge. So therefore, this is called Neap tides. So we could take this moon, and we could draw it right over here, and we would also have neap tides. But when you get spring tides, by the way, that means that we have neap tides twice a month. Now, look at what's going on here. You have the sun, the moon, both putting high tides at D and E. So you have the lunar bulge here, solar bulge here, solar bulge here. So what that means is that we basically have very high tide, and very low tide. This is spring tides. It has nothing to do with the season called spring. It means that they spring up. So we would have huge tides here, huge high tides there, huge high tides in this situation. This would also be called spring tides. That's why we have spring tides twice a month.
Okay.
Kill it.